Hello students, in the last few lectures I have discussed about chemical equilibria and today I am going to discuss your ionic equilibrium. So, as the name suggests, ionic equilibrium is basically your equilibrium between ions. So, equilibrium between ions, and certainly this can only be achieved when there is ionic reaction. Ionic reaction. Now, first thing we will discuss is why, when you have a reaction which involves ions, okay, a reaction which involves ions. So, reaction involving ion involving ions are when ions are involved in the reaction. So, first ions need to be formed. And so that they can be involved in a reaction. So, how ions are formed? Formation of ion. Ions are formed when an electrolyte is put into the solution. Aqueous solution. For example, if we put NaCl in water, this is your water, NaCl will break and ions are formed. So, Na plus aqueous plus Cl minus aqueous. So, first thing is ions are only formed when a electrolyte is put into the solution. An electrolyte is put into. What is electrolyte? Electrolyte is any compound which, when put into the aqueous solution conducts electricity. When a circuit is formed, a closed circuit is formed, and that is why they derive the name electrolyte, because they conduct electricity. And this is because of they conduct electricity, because when we are putting your electrolyte into aqueous solution, they dissociate into ions. So, if I take water and put any electrolyte, put water and add any electrolyte, it will dissociate. So, electrolyte dissociate into ion, 2 ion, and if we put a electrode, cathode, electrodes such as cathode, anode, and then we complete the circuit, then you have light. There are two types of electrolyte. One is your strong electrolyte, and second is weak electrolyte. Now, let us discuss what we mean by a strong electrolyte and weak electrolyte. So, a strong electrolyte is electrolyte which completely dissociates into water, almost completely. Into water. For example, if you take AgNO3 in water, it will form Ag plus or if you take for example, HCl, it completely dissociates H plus plus Cl minus, and this is in aqueous. So, it is almost like 100% dissociation, almost 100%. So, for example, if I take 4 molecules of zinc sulphate, which is a strong electrolyte. Suppose I take like this zinc and then I make this sulphate ion. If I put this into a beaker with water solution, what will happen is almost all will dissociate. So, this is 4 molecule of zinc sulphate, this is suppose zinc 2 plus and this is your sulphate 2 minus. So, you will get something like this. So, you have a 4 molecule of zinc 2 plus and 4 molecule of sulphate ion, 4 zinc 2 plus and 4 sulphate ion. So, this is an example of your strong electrolyte. Now, if suppose I take a weak electrolyte, for example, acetic acid is your weak electrolyte, and if I suppose take 4 molecules of acetic acid and let us denote this by and you can take something like this. So, this is your acetate ion CH3COO and this is your H plus. Okay. Now, if suppose I put this in water, this is your water, only few molecule of acetic acid will dissociate, others will remain as your undissociated molecule. Undissociated molecule. Undissociated molecule. And so, these are called your weak electrolyte. So, any compound which is not completely dissociated, but not completely dissociated is called weak electrolyte. Weak electrolyte. Now, why some compounds are strong electrolyte and some compounds are weak electrolyte? Why some compounds are strong electrolyte and some compounds are weak electrolyte? This will depend on behavior of ion in water. Behavior of ion in water. Okay. What do I mean by this? That there are some ions they simply get hydrated when comes into contact with water. In contact with water. For example, if you take Na plus ion and put in water, what you will get is Na plus hydrated. Whereas, if I take CH3COO minus and put in water, this is basically what you are going to get is CH3COOH plus OH minus. So, there are two different behavior for two different ions, One type of ion will simply hydrate, whereas another ion, for example, CH3COO minus will react with water to give your acetic acid plus OH minus ion. Depending on the kind of behavior an ion shows in aqueous solution, we have a strong electrolyte or weak electrolyte. Generally, in the case of a strong electrolyte, both the ions, for example, Na plus, so both the ion cation and anion, when they react with water, they simply gets hydrated. Similarly, Cl minus plus H2O will simply get hydrated. On the other hand, in case of weak electrolyte, for example, acetic acid, the behavior of one of anion and cation will be different, whereas H plus will be simply gets hydrated CH3COO minus plus water, there will be no hydration, there will be a reaction which will give you CH3COOH plus OH minus. And this is the reason why in a weak electrolyte, dissociation is not complete. In a weak electrolyte, dissociation is not complete. Now, there are different kinds of electrolytes, and generally you can come across three different kind of electrolytes. One is acid, second is base, and third is your salts. Acid, base, salt. So, Arrhenius definition of acid is any compound which is capable of giving H plus ion, capable of giving H plus ion. For example, HCl, acetic acid, so HCl in water gives you H plus ion plus Cl minus ion. Since H plus has been given by HCl, HCl gives H plus ion, HCl is capable of giving H plus ion, HCl is an acid. Whereas, any compound which is capable of giving OH minus is called a base. This is Arrhenius definition for an acid and a base. So, sodium hydroxide put in water will dissociate into Na plus OH minus. Since NaOH is capable of giving OH minus ion, so NaOH is your base. NaOH is a base. I explained you about a strong electrolyte and weak electrolyte. Similarly, this kind of concept can also be applied for acid and base. So, any acid which is a strong electrolyte, is a strong acid. For example, HCl in water completely dissociates into your H plus aqueous plus Cl minus. This is almost complete dissociation. And so HCl is a strong electrolyte, and so HCl is a strong acid. So, any acid which is a strong electrolyte is a strong acid. whereas an acid which is a weak electrolyte is a weak acid. For example, if you take acetic acid, it dissociates to give CH3COO minus plus H plus. This is a weak electrolyte. It does not dissociate completely. Only a small amount of acetic acid is dissociated into your acetate ion and H plus ion, and that is why acetic acid is a weak acid. Acetic acid is an weak acid. Similarly, we have strong base. Again, a strong base is a strong electrolyte, and so it dissociates completely. Dissociates completely, and then you have, for example, you have NaOH. When put into water, it gives, this is complete, almost complete dissociation, This is almost complete dissociation. Now, what about salts? Salts can be of two types: soluble salts. For example, NaCl, AgNO3, these are quite soluble in water, whereas there are some salts which are insoluble, it means sparingly soluble salts. So, solubility is very low. What I mean by insoluble salt, that solubility is very low. We can use another term, your sparingly soluble salt, So, these salts, for example, AgCl, this salt does not go completely into solution. So, generally they are weak electrolyte. So, sparingly soluble salts are weak electrolyte, whereas soluble salts are your strong electrolyte. So, salts can be of two types: soluble salt, insoluble salt. Soluble salts are strong, a strong electrolyte, whereas insoluble salts are weak electrolyte. So, a strong electrolyte or soluble salts completely dissociated. They are completely dissociated in aqueous solution, completely dissociated. These are your strong electrolyte. they are a strong electrolyte. On the other hand, you have sparingly soluble salts, something like AgCl, silver chloride, gives you Ag plus Cl minus H, and here it is a reversible reaction. What does this mean is AgCl is not completely dissociated. Only part of AgCl will be in solution, and that part will be dissociated, whereas other will go out of the solution, other will go out of the solution, and that is why these are examples of weak electrolyte, since it does not completely gets associated dissociated. Now, after the discussion about acid, base and salt, acid, base, salt, we will discuss how to apply equilibrium concept into this, But before that, I will like to give a concept of what is known as pH scale, which provides us an idea about your whether a solution is acid or a base, Okay. So, first, how do we know whether a particular solution is acid or base? So, if I take solution which is basically salt in or any electrolyte in water, electrolyte in water, when it will be a acidic solution, when it will be a basic solution. Okay. So, first thing is when concentration of H plus ion is greater than concentration of OH minus ion, then we say solution is acidic. Second, when concentration of H plus ion is less than concentration of OH minus ion, then we will say the solution is basic. Whereas, when H plus ion is almost equal to OH minus ion, then the solution is called neutral. So, suppose if we have sodium acetate. So, if we put salt into water and we want to know which kind of solution this is, whether it is an acidic solution, basic solution or neutral solution. So, if suppose I take NaCl, take one example, simple example, NaCl into water. So, what we will get? It is, if I put sodium chloride into water, what I will get is Na plus plus Cl minus. This is almost complete dissociation. Na plus will convert into Na plus. So, this is hydrated sodium plus, this is hydrated chloride ion, they will form in equal amount, this will be 100% dissociated. So, you can see that in this reaction neither H plus is formed not OH minus is formed. Whatever H plus will come from H2O. H2O, and the concentration of H plus and OH minus will be equal. Equal to this, and so aqueous solution of NaCl is neutral. Aqueous solution of NaCl is neutral. Now, take solution of HCl. So, when we put HCl into aqueous solution, it breaks to give H plus and Cl minus ion. There is also dissociation of H2O, and that will give you H plus OH minus ion. But we know that H2O is a weak electrolyte, and so amount of H plus and OH minus obtained is very small, in comparison to H plus which we have got from HCl. So, H plus from HCl is generally quite greater than OH minus ion concentration. Since H plus ion concentration is greater than OH minus ion concentration, the solution is solution of HCl in water is acidic. Now, think about a salt such as sodium acetate. What will happen in this case? Sodium acetate. So, we took sodium acetate and just put into the water solution. Now, question is whether this is a basic solution, acidic solution or neutral solution. So, let us think about this. This is a soluble salt. What does that mean is this will completely dissociate. Any soluble salt completely dissociates into, almost completely dissociates into water, into their ions. So, first thing this happens. Now, what will happen to these ions when they come into contact with water molecule? So, Na plus water, we know Na plus gets hydrated. So, what about acetate ion? Acetate ion plus water will give you CH3COOH plus OH minus. That is what we know. Okay? And so, now you can see that in the solution OH minus is generated. So, the solution will be your basic. So, generally salt of weak acid, which is acetic acid, and salt of a strong base is always basic. That is what we know. Salt of weak acid and salt of a strong base. This is a strong base, which is your sodium hydroxide, is always basic. It goes by the which one is strong, and this is simply because acetate ion in contact with water will go acetic will give acetic acid plus hydroxyl ion. Now, we can think about a salt of your strong acid, which is your HCl, and your weak base, which is ammonia solution, In this case, again salt in water will completely dissociated. We know Cl minus plus water will give you Cl minus hydrated. Okay. Whereas, NH4 plus reacting with water will give you NH3 aqueous plus H3O plus. Now, you see this is basically H plus ion, and so in the solution H plus ion is in excess, and so the solution is an acidic solution. Now, once we understand whether solution is acidic, basic or neutral, now we are going to define a scale by which we can know that a solution is acidic, how much acidic it is, whether it is a strong acid or weak acid, or a strong base, weak base. How do we get the quantitative measurement of acidity and basicity? The scale which we use is called pH scale. The scale which we use to quantify the acidity and basicity is called your pH scale, and pH is defined as minus log activity of H plus ion. Activity is your actual concentration of H plus ion, real concentration. H plus ion. Activity is defined as multiple or two different quantities. One is called activity coefficient into concentration in molarity. So, concentration of H plus ion in molarity. So, this is your gamma H plus, which is activity coefficient. So, pH scale is used for quantitative estimation of acidity and basicity, and this is given by minus log activity of H plus, where activity of H plus is gamma H plus into concentration of H plus ion. Activity of H plus ion is 1, almost 1 for dilute solution. And so, your activity of H plus ion in dilute solution is almost equal to H plus ion. And so, in dilute solution, we have pH is equal to minus log H plus ion. And similarly, we can define POH, and that is simply minus log activity of OH minus ion, and again in dilute solution this is equal to OH minus ion in dilute solution. So, for example, if I take 10 to the power minus 4 molar HCl solution, 10 to the power minus 4 molar HCl solution, we have since HCl is completely dissociated into water. So, what you will get is 10 to the power minus 4 molar of H plus ion and 10 to the power minus 4 molar of Cl minus, 10 to the power minus 4 molar of H plus ion and this. And so, pH will be simply equal to minus log since this is a dilute solution, and so we can simply write pH is equal to 4 for 10 to the power minus 4 molar acetic solution. So, if suppose we have another solution with, in this case your pH will be simply minus log minus 3, and so this is pH 3. So, now you can see that if I take 10 to the power minus 4 molar HCl and 10 to the power minus 3 molar HCl, pH will be 4 and pH will be 3. Now, let us think of if pH is high, what does that mean? pH, if pH is high, then concentration of H plus ion will be low. Okay? So, here pH is low, concentration of H plus ion 10 to the power minus 3, which is greater than 10 to the power minus 4. So, higher the pH, lower the acidity, you can say strength. As we go towards higher pH, H plus ion concentration decreases, and so you have lower acidity. Similarly, we can calculate POH, and POH is equal to minus log OH minus ion, where OH minus ion, this is only valid when we have a dilute solution. So, suppose we take around 10 to the power minus 4 molar sodium hydroxide solution. Again sodium hydroxide will be completely dissociate into sodium plus OH minus. So, OH minus concentration is going to be 10 to the power minus 4 molar, 10 to the power minus 4 molar, and so POH of the solution will be minus log 10 to the power minus 4, and that is equal to 4. So, pH of a strong electrolyte can be pH or POH of a strong electrolyte or a strong acid or a strong base can be easily calculated. But what about weak acid? Weak acid, for example, acetic acid. Weak acid, we do not have complete dissociation. we do not have complete dissociation, it is only partially dissociated. So, if I take 10 to the power minus 4 molar acetic acid solution, I cannot say that H plus ion concentration is 10 to the power minus 4 molar. No, since acetic acid is a weak electrolyte. Now, how to calculate pH of this? So, since this weak electrolyte does not completely dissociate, they are a kind of reversible reaction, which means some are in associated state and some are in dissociated state, we can apply the concept of equilibrium. And since this is the equilibrium when ions are involved, where ions are involved, that is also known as ionic equilibrium. This is also known as ionic equilibrium. So, if I take the case of this weak electrolyte, which is your weak acid also, we can simply apply the equilibrium concept K, and K is basically your product concentration of product and this constant is called ionization constant. So, if we know the ionization constant of a particular acid, then we can calculate the value of H plus ion, and that H plus ion can be used to calculate pH. So, it is simple that acid, in case of weak acid, the concentration of the acid, weak acid, is not equal to concentration of H plus ion. So, weak acid, weak base or weak base, concentration of acid or base is not equal to concentration of H plus ion or OH minus ion. OH minus ion in case of base, H plus ion in case of base. We can calculate H plus ion or OH minus ion in such case using the concept of ionic equilibrium. Concept of ionic equilibrium. So, the way we calculate H plus ion is, so for acid like HA, which is weak acid, we can simply write H plus ion into A minus divided by or we can simply also write, since we know that HA will be dissociate like this in H plus plus A minus, the concentration of H plus is equal to concentration of A minus. So, we can simply write H plus this, and for A minus H plus, since this is equal to, they are equal, and so you just write HA. So, HA plus a square is equal to your Ka into H, and so H plus is equal to your square root of K A into H, square root of K A into H. H plus is equal to square root of K A into H. So, this is for your weak acid. We can again, if we want to calculate pH, we can simply put minus log H plus, and this will be again minus log. In place of H plus, you can just put this K A into H A. We can write pH is equal to minus half for this log K A into H A is equal to minus half log K A minus half log H, and this is simply equal to half P K A minus half log H. So, this is the way we can calculate pH of a weak acid, pH of a weak acid. Similarly, we can also calculate pOH of a weak base. For example, your ammonia solution. Ammonia solution. So, pOH of weak base. So, pOH of weak base is given by Kb is equal to NH4 plus into OH minus by ammonia. And now, we can see that in this case also NH4 plus ion and OH minus ion will be equal. So, you can simply write OH minus square by ammonia, and so OH minus ion concentration will be given as Kb into NH3 concentration under Kb into NH3 and under root. So, what we have seen in this lecture is that we discussed about ionic reactions. This happens in case of electrolytes. Then we discussed about nature of ions, how they react with water. Then we discussed about a strong or weak electrolyte, and then finally, we discussed about weak acid, weak base, weak sparingly soluble salts, and how the concept of equilibrium can be applied in this. Thank you.